Hey guys, what's up? I'm just going to try to do an abbreviated review of what we've learned in electric circuits. So we're going to start with section 4, and this is basically everything that we've learned in it. We'll recap some of what we learned in section 1, 2, and 3. So we're going to be looking at complicated circuits. At first, they look kind of intimidating. But we really want to look at what does it mean to be in series and what does it mean to be in parallel. So these two definitions are very helpful. And looking at how those definitions relate to these definitions are also very helpful. So in series, they have a single junction together, so there's one path. So in series, one path, what goes through one bulb is going to go through the other. And in a parallel, it's going to split. So what goes through one bulb or branch does not go through the other bulb or branch. So let's look at a quick version of this. So I have a single. Here we have everything is going through the same branch. So these two bulbs are in series with each other. And here we have two bulbs that are parallel. See how the electricity, the current is splitting up and then it's going back to the battery. That is also very important. Things also have to go back to the battery. Here I have an example of a complex circuit. I can't say if this is in series or if it's in parallel because I have a little bit of both. So I'm going to close the switch. So right now it's in series with each other, but I put a switch here, and what happens if you add something in parallel? Wrong switch. Here, let me just hit that. Okay. I got to find a better spot for that switch so I can. All right, I got to add another wire here. And now I'm going to make it a little easier to add this bulb. There we go. And now we have a switch. And so when we add a bulb in parallel, this actually got brighter. All right. So let's look at what's happening in these. So we can measure the current. We actually, in this class, we mainly say we can't say for sure what the current's going to be. We don't have those kind of tools yet. We are just looking at brightness, and brightness is an indicator of current, and that's important to understand if you're looking at for the reasoning part of this. So if I look at current across the battery in a single circuit, this has a brightness of 0.9. We notice that this has a brightness of 0.9 as well. However, we have two brightnesses that are at 0.9. So what we're going to say is that across the battery, it's going to be 1.8. So they add up. So what rule did we devise? That adding bulbs with another path is going to increase the current. All right. Now, what happens if you add a bulb? So we call that parallel. See, this is parallel. It's going at the same time. Whereas a series, like a TV series, you watch one after the other, what happens to the brightness? Well, the brightness goes down. So brightness is an indicator of current. So the brightness went down, so the current went down. So if I measure this is going to be 0.45. All right? So in general, we can say if you add bulbs in series, the current's going to go down. If you add bulbs and another wire, so if you add bulbs in parallel, the current is going to go up. So this is kind of surprising. This surprised me. If I add a bulb in another bulb to the circuit, this actually gets brighter because we added an extra path. So we're going to use those definitions to look at more complicated circuits. So if I look at, here's a quick review of, let's present this. If I have a quick so we say that E and F are in series and branch E and F are parallel to D. We could say bulbs B and C are in parallel and branch BC is in series with A. Please look at this slideshow if you need more help. We're just going to look at some more complicated circuits. I'm not too worried about switches for this quiz. I'm more interested in what happens, what are the observable changes. So if I close this bulb, we are adding a bulb in parallel, increasing the current. That's what we said. We add bulbs in parallel, we increase the current. So current is going to be greater here. This is a separate branch, so this current is not going to be affected. But by closing this switch, we increase the current across the entire battery. This will be big, understanding how the complex circuit works. So we can break this down. Looks like a lot, but you see that D and E are parallel to each other. And then branch D and E are in series with B. Then we could consider this a whole branch, and we could say branch B, D, E is in parallel with A and C. Why are they parallel? Because it splits. These are on completely different paths. We had more fun circuit diagrams, and you had some fun reading it. I hope you guys had fun in this unit. And yeah, look through this stuff. You really should understand through 4.8, and through 4.12 was more of how we apply it. So circuits and lights, on to you guys.